Hey M218, today we're here to talk about our area formulas. So from the iPad activity the other day and probably from like junior high, we know that the area of a rectangle is base times height. So just remember, this is my base, this is my height. If you would rather say length times width, that works as well. I'm going to stick with base times height, but you are more than welcome to use length and width. Okay, so this now leads us to the area of a square. A square, remember, a square is a rectangle. So if the formula for area of a rectangle is base times height, then that has to work for the square as well. Okay, and it does work, but remember a square has all sides congruent. So if all sides are congruent, that means that the base and the height are actually the same number. So maybe you want to say base squared. Maybe you want to just call it the side length squared. Makes no difference to me. Area of a square, same as the area of a rectangle. Okay, next up, area of a triangle. So remember, for the triangles that we want to find the area of right now, we have a right angle in them. So as soon as I have a right angle in them, I can remember that a right triangle, I can fill in the rest of the rectangle on it. And again, we saw this in the iPad activity. So my triangle that I drew is half of a rectangle. So if the area of the rectangle is base times height, then I cut it in half. I take out this half. Okay, let's X that out. And then the formula has to be base times height divided by 2. I want this half down there. Okay, cleaning up our page a little bit. Next up, we have the parallelogram. So again, on the iPad activity, we got a good glimpse of this, but let's be a little bit more formal. So here's my parallelogram. I can look at this one of two ways. First of all, I can think of it as a rectangle that has been pushed over, right? If I take and I apply some force right there and push a rectangle over, I get a parallelogram. Have I changed its area by pushing it over? No, I haven't. So this leads me to the conclusion that the area of the parallelogram has to be the same as the area of a rectangle. Okay, so maybe you don't like that explanation. Let's look at this a little further. Let's take a look at what happens if I were to cut this part of the parallelogram off and relocate it over here. Okay, so I'm going to take this triangle here and I'm going to send it to the other side. Okay, and removing this and moving it over here, I've now created a full out rectangle. So if I trace that, let's see if I can get that in purple. If I trace the complete figure in purple, so now you'll see, what am I looking at? I'm looking at a rectangle. What's the area of a rectangle? Okay, we know this, base times height. So if the area of a rectangle is base times height, I've given you two ways now to justify that the area of the parallelogram is also base times height. Okay, so I'm noticing a pattern here. Area of a rectangle, base times height. Area of a square, base times height. Area of a parallelogram, base times height. Area of a triangle, base times height divided by 2. Okay, if I had to guess, for the area of a trapezoid, I'm going to say base times height. The problem with the trapezoid is my upper base and my lower base are two different lengths. So how can I make the formula base times height work? The answer is I average them. I take the top base, which I'm going to call B1, okay, base 1. I'm going to take this one, I'm going to take this one, I'm going to add them up and divide by 2. We've already seen this process of adding and dividing by 2. We did this in our trapezoid unit to find the length of what we call the mid-segment or the median of the trapezoid. I prefer mid-segment. Some books, I think our book calls that the median. Okay, so when I want to find the area of the trapezoid, I'm going to use the median as my base and then my height. So the area of the trapezoid, if I write it like this, the length of the median times the height, look at the pattern. Okay, the pattern all the way down, base times height, base times height, base times height divided by 2, base times height. It's still base times height. Which base? The average of the bases. But we still now, by writing it this way, you see that pattern a little bit closer. Okay, so before we get to the kite, I've changed, instead of saying the median times the height, again, I've put it back in terms of bases. So the average of the bases times the height, base 1 plus base 2 divided by 2. Okay, great. So moving on to the kite. Here I've drawn you a kite. Now, really, you could break apart a kite into 4 different triangles. These two triangles up top are congruent, these two triangles below are congruent. And you can find the area of each of the triangles and add them together because we know that about area. I can piece it together as the sum of its parts. Okay, so let's try this a little differently. Instead of thinking of it as 4 separate triangles, let's think of it as 2. The upper triangle on top and the bottom triangle down below. Okay, so the area of this top triangle then is base, DB, times height, AE, divided by 2. Area of the bottom triangle right here is the base, DB, times the height, EC, divided by 2. So the area of the kite must be this plus this, right? Okay, this is totally true, but that's not a helpful formula. This is not something that I'm going to memorize the letters to and really go this route. Let's see if we can simplify this because this is not user-friendly to me right now. Okay, so giving us some space and cleaning things up a bit, here's what I've done. I took a look at this, I said, well, the left side has a dB, the right side has a dB, so let's factor it out. Plus, I have a common denominator. So let's keep the common denominator. Let's put it all together in one fraction. So now I've got this. But this isn't any better than this. So that one last step, take a look at the inside right here. What's AE plus EC? Well, AE plus EC, that's AC. Okay, putting AE and EC together and getting AC, look what I just got. The formula for the area of the kite, dB, hey, that's one diagonal. AC, oh my gosh, that's the other diagonal. So we just proved, okay, I took you through the long way. Do you have to do this every single time? No. Could you? Sure. I just proved to you that the area of a kite is diagonal 1 times diagonal 2 divided by 2. Okay, so what does that look like? Area of a kite, here's what it looks like. Diagonal 1 times diagonal 2 divided by 2. Okay, notice the similarity to the area of a kite, it goes back to your triangle. It goes back to base times height, base times height, base times height, base times height. Diagonal 1 times diagonal 2, that's kind of like your base and your height of your two triangles. So it is that idea of base times height. Okay, make sure you do not mix up the trapezoid, which is base 1 plus base 2, and the kite, which is diagonal 1 times diagonal 2. Remember, this is your base, this is your height. This is your base, this is your height. So every one requires that multiplication sign. Okay? Last but not least, let's move on. We've got the area of a circle. So remember, a circle, we have to know where the center is. We have to know where the radius is. Okay? Once we know the radius, I mean, this is old news. Area of a circle, pi r squared. What else falls in here? The area of the sector, the area of the segment, and I'll get into that in the example sections. Okay, and there you have it. There's our list of all the formulas for sections 11.1 through 11.4, plus the circles out of 11.6.